Let's take a look at a subtraction problem. So this problem, 140 minus 125, you might want to line it up like this, especially I lined it up like this for you, and you might want to cross things out and borrow. Borrowing is not language we're using anymore because when you borrow something, you have to give it back, and we never give it back, so we don't talk about borrowing anymore. But if I pose this question to you, say the price of something is $125. You charge your client $125. They give you $140, and that extra, that difference, is the tip. So you might want to figure out what that tip is, how much it is. So in your head, you're probably not going to like write this out and then do some crossing out to try to figure it out, because it can be solved much more quickly and simply than by using the standard algorithm. So you might say, well, 125, I like tens better. Tens are much more easy to operate with. So maybe I'm just gonna bump that up in my head to 130. And then 130, if I jump 10 more on the number line, that gets me to 140. Maybe you're thinking this in your head, maybe you're not thinking number line, but you're thinking, oh, from 130 to 140, that's 10. But then, oh, well, I still have this distance too I have to factor in. Well, that's 5. So really, this distance is 15. That difference is 15. So 140 minus 125 is 15, because the difference between those numbers is 15. So if you kind of jump up to the nearest 10, you're using a compensation strategy. Some other folks might say, well, if I have 125 and I jump up to 145, I jumped 20. And now I just need to jump back 5 to get to 140. So again, the distance is still 15, but you got there a different way, plus 20 minus 5. So there are lots and lots of different ways to kind of think about this, to think about manipulating these numbers. But a lot of the approaches that teachers are using right now are actually grounded in the approaches that most folks use when they're doing mental math.